So a cylindrical object is placed 50 centimeters in front of a plane mirror, and in part A you want to draw a ray diagram for this object showing how this observer is going to see the image in the mirror. So there are a bunch of light rays coming off this object, and those rays are hitting the mirror and reflecting back into the person's eye, but just for the sake of simplicity and to make the diagram a lot cleaner, I'm just going to draw two of those rays, one coming from the top of the object and one coming from the bottom of the object. So the ray coming from the top of the object is going to go in a straight line until it hits the mirror. I'm going to draw an arrow on that indicating the direction of the ray. Once it hits the mirror, it's going to bounce off at the exact same angle and enter the person's eye in that direction. And if I draw a normal to this, remember normal is the line perpendicular to the surface, in this case perpendicular to the mirror, so I'm just going to draw a dotted line to represent the normal, and the angle of incidence, which is this angle right here, is exactly equal to the angle of reflection, which is this angle right here. If I draw a second ray coming off the bottom of the object, it's going to be here, and it goes up and hits the mirror, and then that one also reflects back into the person's eye. And I'm going to draw the two arrows on this indicating its direction, and I'm going to draw a normal for this one also, and this angle is equal to this angle. So what is it that the person is actually observing? Well, according to the person, they have to pretend like the mirror is not here. They're seeing these rays as if they were just coming from over here somewhere. So I'm going to backtrace the reflected part of the rays on the other side of the mirror with a dotted line. So for the one that I drew in red, if I looked at the reflected ray and just drew that one, just keep it going backward over to here, and then same with the one in blue, just take that one and reflect it backward down here, you'll see that it forms an image of that cylinder over on this side of the mirror. And that's what it is that the person is seeing when they look in the mirror. And then for part B, it just says, what is the image distance? Well, you know that the image distance for a plane mirror is just equal to the negative of the object distance, and the object distance was given as 50 centimeters, so we can just say the image distance is negative 50 centimeters, because this is a virtual image, and the image distance is a negative number every time you have a virtual image. So that's the distance from here, the mirror, to where the object is.